This is lesson 5.5, the laws of logarithms. In this lesson, the focus will be on how we can develop and use these laws of logarithms. First, let's start by taking a look at them. You'll notice that we have three different logarithms right here, and I'm going to discuss them in a second. The interesting thing about each one of these is that they parallel, so if you want to write this down, they parallel the exponent laws. So you might remember those exponent laws that say that if you have the same bases, and the bases are being multiplied, you add the exponents, or if they're being subtracted, you divide them. Well, the same thing happens here. And so you'll notice that we have three, as I said. We have a product, quotient, and power law, exactly the same as exponents. What we can say right here is that when we have log base b of xy, so x and y are being multiplied, we just add them together, very similar to exponents. When they're being divided, we subtract the exponents. When we have some x to the power of k, what we do right there is the k comes in front and we basically write it like so. Okay, so those are three different laws of logarithms that we're going to be looking at in this lesson. This lesson really has two parts. The first part, we're going to look at how each of these laws of logarithms comes to be. So I'll be talking you through a couple of different proofs. These proofs are definitely fair game on any type of summative assessment that I give you, so make sure you're prepared for those. And then we'll take a look at some examples where we actually use these laws of logarithms. So let's start by developing these proofs right here. We'll start with the product law proof and work our way across. What you'll notice with these is that once you have the product law proof kind of figured out, these other ones follow the same order. So I'll start by writing the product law. It says when we have log of base b of xy like so, as you know, it's equal to, when we're multiplying these together, we can write it as log base b of x, and then we add it log base b of y. Okay, so that is the that is what we're trying to prove in a sense right here. Okay, so that's where I'm trying to get to. I'm going to use the yellow to show how we can make our way down to get that. All right. So the first thing I'll do is I'll use a let statement. Let log of base b of x equal m. Okay, so I'm just making this equal m. And then I'll do the same thing, but I'll let log of base b of y equal the letter n. All right. Now, if you remember what logs essentially mean, it means what number do you raise b to in order to get y? And what you'd have to do is you raise b to the power of n in order to get y. So what I'm going to do is I'm going to write these now in exponential form, such that I could say x is equal to b to the power of m, and y is equal to b to the power of m. So again, b raised to something gives us x. Of course, it is b raised to the power of m gives us x, like so. Okay. So if we continue down here, now that we know that, we can use the factor that. So I'll write so. I know that if you take x and you multiply by y, so xy, essentially being that's multiplied, it must be the same thing as bm times bn, like so. And if you remember your exponent laws, the exponent laws say if we have the same base, then we just add the exponents. So we have b to the power of m plus n, like so. Okay, so now that we have that x times y is equal to b to the power of m plus n, I'm going to put this back in terms of a logarithm. Remember what logarithms mean. It means if we have some log of base b, right, and we raise it to the power of something, it should give us xy. So log base b of xy must equal m plus n, right? So if we take b and you raise it to the power of something, it gives us xy. That's what it was just saying right here. Okay? And then finally, if we go back to our let statement right here and here, we can go and replace those. So we can say that log of base b of xy is equal to, right, I'm replacing m and n together, such that we have log of base b of x plus log of base b of y. All right, and so lo and behold, we have proven that that is the product law. All right, let's go and do a different one right here where we'll talk about what the quotient law is. So the quotient law is very similar. We have log of base b of x over y is equal to the exact same thing. Of course, this time we're just going to subtract. All right, so I'm going to just use this to save a little bit of space right here, that these are going to be the same. So I'm just going to slide those over. We're using the exact same let statement. All right, and I will do the exact same thing right here with these two to show that that is the case. Okay, so now if we want to go and prove this thing, I'll use the yellow pen. We can say that x over y is equal to, if we follow the same fashion right here, x over y must be b to the power of m, all divided by bn. And if you write those as a single power, we could say that that is b to the power of m minus n, like so. Okay, so then again, if we go and write it in logarithmic form like we did right here, we have log of base b, so b raised to the power of what is going to give us xy, sorry, x divided by y. So we write log base b of x over y is equal to m minus n. And then finally, just like we did right here, we're going to replace our m and n such that we have our original quotient law here, such that we have log a base b of x minus log a base b of y. Okay, and that was what we were trying to prove. Okay, now finally we're going to deal with the power law. It works in a similar fashion. Because I've done my let statements over there, I'm just going to renew my let statements just so you can see them in kind of a nice cleaned up way. Let's start by writing what the power law is, though. The power law says that we have log a base b of x to the power of k. That is equal to k, so the k kind of comes out in front of log base b of x. Okay, so the first thing I will start with right here, just like I've done for the other ones, is I'm going to do a let statement. You'll notice that this let statement is going to be the same as ones that we've had before. The only thing that or that's different is that we only need one let statement right here. So log base b of x we're going to make equal to n, similar to kind of what we've done over there. And then what we can say from this is that we know that x must be equal to b to the power of n. Okay. So the next thing I'm going to do from here is that I'm going to take each one of these sides and raise it to the power of k. And so we raise it to the power of k, we have x to the power of k is equal to bn to the power of k, like so. Next, I'll just simplify this and I'll write x to the power of k is equal to b to the kn, or nk, makes no difference. Next, what I'll do is I will take the log of base b of each side. So this becomes log of base b of x to the power of k is equal to log base b of b to the power of kn. And this uses this rule that we explored in our previous lesson. If you recall what's going to happen right here, so this side right here is just going to stay the same. But when you have a log of base b raised to that, that same base right here, it's just equal to the power. So that would just be kn, like so. Okay, and then finally right here, what we will do is we will sub back in this let statement that we had right there, such that that n is going to get replaced. So we can say log a base b of x to the power of k is equal to k log b of x. Okay, so I've just taken this right here and I put it in for that n, and you see that the k is out in front. So those are my three logarithmic laws. Now what we're going to take a look at is how we can put these into practice. Example 1 says, simplify each expression, then verify with a calculator. I'm going to leave out the verification with the calculator, although I'd suggest that when you guys are going through your assignments that you use that in order to check your work. So all we have to do here is put those logarithmic rules into play. So if you take a look, let's try to identify which logarithmic rule that we have, whether it's going to be the product, quotient, or the power law. So the first thing that I would get you to see here is that when we're adding, that's the same thing as essentially multiplying them together. Right here, so we are using the product law. So we can write this as log of 7 times 8, which just gives us log of 56. That's straightforward. I think you're going to find these relatively easy, perhaps, dare I even say, enjoyable. If you put this into your calculator right there and put this one into your calculator right there, they should give you the same answer. The next one we have right here, 5 log of 2, uses our power law, and that says that we can go and take log of 2 and raise it to the power of 5, like so. Okay, and if you simplify that, 2 to the power of 5 is just going to give us 32. So again, if you were to take this original one, put it into your calculator, and this one, it should give you the same thing. Okay, and the last one we haven't taken a look at, obviously, is using the quotient law. And so this one just says that we can rewrite this as log of 80 divided by 16. And when we simplify that, 16 goes into 80 5 times, so this is log 5. All right, and again, those two should be equal. Okay. So let's go and do it a little bit differently in example 2 right here. You'll see that example 2 says write each expression as a single logarithm. So we can say that log of x is just going to stay the same, but the 3 right here, if you recall, that's going to use the power law, so this is going to become log of y to the power of 3. So we're going to write this as log of y to the power of 3, just like so. And then remember what happens when we are adding them together. That's going to use our product law. So we can rewrite this as log of x, y cubed. Okay, so that one used two of them. So we're just combining some of these logarithmic laws. All right, let's go to B on the next page. So B, you'll see that we now have three different terms right here. So log of x, I'm just going to keep it the same. This is going to become plus log of y to the power of 2 minus log of z to the power of 4. Now, if we take care of these one at a time, you'll notice that this becomes log of x plus log y squared. That's just going to use our product law. So we can rewrite that as log of x, y squared, right? So that's product, meaning we're multiplying them together. And then the minus means that we should just be dividing by z to the power of 4. Okay, so you'll notice that this one has log of base 2. All the other ones we didn't write the base, so we assumed it was 10. So this one's going to be a little bit more complicated. So we'll write it as log of base 2 of 6. And then the next one right here, how are we going to write this negative 3 in terms of a logarithm? Well, we're dealing with base 2 here. So 2 raised to the power of 3 right here is going to give us 8. So we're going to write log of base 2 of 8, right? Because this is saying 2 raised to the power of something will give us 8. Well, we know that 2 to the power of 3 will give us 8. Okay. Now that we have the same bases right here, we can use our logarithmic laws, and we can say that this is log of base 2. Remember, when we're subtracting, that's going to be our quotient law. So we have 6 divided by 8, and of course we can simplify that as log of base 2 to the 3/4. Okay. Let's go to example 3. Moving right along, I think you can see that these are relatively straightforward. So this one, what we're doing is we're kind of busting out of the logarithmic laws. So we're writing this in terms of log A, log B, and or log C if that's given. So if you recall, what's happening right here is I would say there's a couple things going on. We have a power to the 2, so that 2 must have been out in front at some point. We also have a division going on. So I'm going to write this as log of A, and we're going to deal with the division first. So this must have been minus log of B squared. And then where did that squared come from? Well, that squared must have been, the 2 must have been out in front. So I can write this as log of A minus log of B, but the 2 now, as I just said, is going to be in front. Okay? So this is us kind of going backwards, right? We've been going in the other direction from here to here. Next one right here, you'll see we have lots of shenanigans going on. I'm going to split this up in having log of A squared first. And then I have plus, because these are being multiplied, so I know I need to add them, log of b to the 1/3. This is being divided, so I need to subtract. So just using all my logarithmic laws, like so. And then finally from here, I have some powers going on, and so I know that the 2 must be in front of my log, so 2 multiplied by the log of a plus 1/3 log of b, and then this one is good to go, so we can just leave it as log of c. All right. Lastly, let's go on to example 4. I think I have 2 more right here. Okay, so example 4 here says that we're going to evaluate each expression. So our final answer here is actually going to be a rational number. So we're just using our laws of logarithms once again. A little bit more complicated. We're adding more stuff to the mix. So using my laws right here, what I would know is these are both log base 9, so that's good that they're the same. And what I see right here is I have a 3 out in front, so I'm going to take 6 and raise to the power of 3. So I have log of base 9 is equal to, or is the same as 6 to the power of 3, minus log of 9, 72. So I got nothing going on there. What I'm going to do just to simplify right now is this 6 to the power of 3. That is the same as 6 times 6 times 6, which is 216, like so. And then finally, because we have the same bases right here, we can use our laws of logarithms one more time, that when we are subtracting, we know that that is equivalent to dividing. So we have 216 divided by 72, just like so. And if you use your calculator, you probably wouldn't know this off the top of your head, but 72 does go into 216 exactly. So we have log of base 9, and this simplifies just to be 3. Okay. Now, this is where we might have stopped before, but what we can do right here is we can do a little bit of simplification. Because I have my base 9 right here, I want to change this to being a 9, right? And so what I will do then is I'll write this as log of base 9 of 9 to the power of something that would give me 3. Now, hopefully you recall that if you take the square root of 9, it gives you 3. The square root in terms of a power, that's the same thing as writing 1/2, right? And we looked at this in our previous lesson, that when you have log of base 9 to 9, that just simplifies, right? These essentially kind of like cancel out, such that your final answer is just the power right there. So my final answer for this works out very nicely. It's just 1/2. Okay. Last one that I have for you right here. Again, getting ever so more complicated. We're going to do the exact same thing we did here. I'm going to write this. They're all log of base 4, so that's good. I'm going to write log of 4, and this is going to become 6 squared. This one is going to become 3 cubed, and this one right here is not going to have a power, so we can just leave it. I will simplify these powers a bit. So I have 6 to the power of 2 is going to give me log of base 4 of 36. Log of base 4 of 3 cubed, that's 27. And then plus log base 4 of the given 12. Okay. Now combining these all together, I'm going to have log of base 4. I have 36 minus the 27, so that means that the 36 is going to be divided by the 27. And then I have the adding the 12, so that means that this is going to be multiplied by 12. Okay. And if you put this into your calculator, if you simplify this, what you will end up having right here, 36 times 12 divided by 27, it simplifies super nicely to give you 16, like so. Okay, and just like we did up here, if you remember what I was trying to do is I was trying to change this to be a 9 to match my base right there. I'm going to change this one right here to be a 4. And this one I think you can see is pretty easy to do. It's going to give me log of base 4 of 4 squared. And remember, when these are the same right here, my final answer is just going to be my exponent. All right. So that concludes this lesson. I know we went through a lot of examples. There's really just 2 things that I want you to take from this. It's what the laws of logarithms are, how to make the proofs work for them, and then you got to see some of these examples in action. All right, that concludes this lesson.